going to be doing a lot of things. We're going to be doing commons, loops and conditionals, if statements, else if, and functions, definitions and calls, things like that. And importing other modules, files, and example problems. See, we've already done C, so we pretty much know a lot of programs. We're doing bubble sort. We've done a couple of algorithms like that. So we will see how we do it in Python. All right. So first things first, we've useful if you want to just do a small program. It is useful, but if you have multiple files, playing around, imports and things like that.
Hello.
Executed in it, so it's more useful compared to, let's say, Notepad or something like that. So how we go about creating any Python file? All right. Now again, we did it yesterday. It's just saving by py. So we go do something like test.py, and that gives us a Python file. Now if you open it in Sublime, open file, test.py. Now we have a blank Python file we can play around with. Okay, first things first. Okay, today we are covering comments. Now comments in Python, single line comments are done with just that, a hash. Okay, hash anything. I execute with Control B in Sublime. So if you want to use Sublime, it's Control B. Anyway, it does nothing. If I give a print statement, test. Okay, whatever. You see, that expects an error. It's doing something unexpected intent. So again, one thing we haven't done yesterday is intents. It's like Python. Instead of using curly brackets, it uses intents to sort the code. The flow of code is broken by intents. So might want to watch out. Anyway, it prints test without looking at whatever this is. That's how comments work. You can do multi-line comments by doing that, and then you can put whatever you like and go on with it. So it's good for documentation. And if you're going to, let's say, look at some project on GitHub or something, you'll see a lot of comments there. Loops and conditionals. Okay, now other programming languages, they have if and else if, but Python does elif. So it's again something to be noted. So how it goes is this, all right? If the condition in the bracket and the colon. Now, as we saw, the everything under the if condition, the statement, it has to be intended, okay, with a tab preferably. So it goes like this. If, and put a condition in the bracket. You don't really need brackets, but let's just go with it. Let's say 3 greater than 1. All right, obviously return true. Again, when we're going with the tab, this will execute, we know that. So let's say this executes, we got test here. And 1, let's say greater than 3. Does not. That's how if statements work in Python. Now all of us have done C, so it shouldn't be hard. Port over, do. What's different is the elif to the next one, and let's say print this was the elif. Just call it else if you want to, but it is the elif. This was the elif. So we can always go with an else in this and have that print something. Print this was the else. And if I give this as false, we notice this was the else. Okay, so what is happening is first checks the topmost condition, then goes to the next condition and else. So it's not like a switch case scenario where you have to break. It's like and an else, elif ladder. Yeah, an if ladder. Anyway, that's how conditional statements work in Python. This is very useful for everything, so keep that in mind. The next thing, for loop. Okay, again, we all know how useful this is in let's say C for iterating through arrays. Now Python has a lot of built-in functions to avoid the for loop, but for loops are useful. In any programming languages, for loops are like the bane of everything runs on these for loops or while loops. So how it goes is for I in range. Okay. Now this is for an iterative loop that goes from one number to another number. How we write in C, we would write something like int I equal to 0, I less than some condition, and I plus plus or I minus minus, something like that. Instead of that, Python has something called the range function. Okay, it's there in every program. You don't have to import anything. So for I in range, let's say 1 to 10, and with a step of 1. So the range function, now this is the interesting part, it takes three arguments. The first one is the initial number, okay, what you're going to start from. Now, just like C has the habit of using this, indexing, the index goes up to the last position of the range. So for I in range, what we get is that we get 1, 2, 3, 4, 5, 6, 7, 8, and 9 with a step of 1. We go with 2, we get 1, 3, 5, 7, and 9. Okay, with a step of 2. Now, this is how the range function works. This is really useful because we can do stuff like this minus 1. Let's say minus 1 is starting in this case, just note that. Minus 10 and give it minus 1. What this is doing is this takes this as the first digit, first number, and it goes on till minus 10. Hmm? And it's with a step of minus 1. So that's a range function, and range function is useful for iteration. Now you can do things without the range. In Python, the benefit is you don't really need to have a numerical indexing for going through arrays or things like that. We use lists and a equal to, let's say, 1 comma 2 comma 3 comma 4 comma 5. Now I just need to say for I in a, okay, let's say array for clarity. Okay, for I in array, print I. So this is like English. Okay, so all you have to say is for I in this particular thing, just print everything. So now if we go for that, we get 2, 3, 1, 2, 3, 4, and 5. Everything in this thing. So if you have to do something like print the product of, let's say, product of all these individual numbers with 3, all you have to do is this. Okay, and now we have 3 times everything in this array. It's just convenient. I mean, more convenient than, let's say, C or C++ or yeah, Java. It's much easier. And the next thing, okay, while. Okay, while is it goes something like C again. All you have to do is while and some condition. Let's say while n is less than 10. And now provided we have n equal to 1 or predefined n something, we can define the block. Now notice, okay, a lot of people coding in Python, they are used to some other language and they default to curly braces, but Python uses spaces. If I don't do spaces right, Python will throw an error. If I give a print statement here and ask you to print I, let's say even if you put let's say n minus equal to 1. See, so that's one of the problems we keep running into. Anyway, uh, so the next thing we're going to deal with is the while loop. The while loop runs in this fashion: while some condition do something that repeats while the condition is true. All right, much like anything else, any other coding languages like this. While we also use tabs for these, print n n equal to n minus 1. Now n plus 1 less than 10, right? It prints all that is. Instead of a for loop, we can use a while loop. And that's how we do a while loop in Python. The next thing we're doing with is we're doing functions. Okay. Now, how we define a function in Python? Function's pretty easy compared to, let's say, doing data type first, something like a void main. None of that. None of that. Python does things very clear, very easy, very easy to understand. It's mostly like English. Define. Okay, what we're doing is defining a function. So def for define. Let's say the name of the function, name underscore function. Okay, just like name character that's allowed to be used. That's that. Let's go with it. Print. Let's say this is from a function. Now, if you're going to call this function, you have to do it in the main body of the program. So how we go about doing it in the main body is the closest to the intent. The indentation is everything in Python. So yeah, we need to be careful of that. Name underscore function. So if I run it now, this is from a function. I don't run this. If I don't call the function, there. Okay, it ran the program. It didn't show any output. And that's that. Again, that's from function. This is how we define a function. We use the intent. This is a tab. This has a couple of spaces. This has 1, 2, 3, and 4 spaces. But that's just to be neat. Yeah, if you're using tabs, it's much cleaner. So go with tabs. And yeah, this is a function in Python. Yeah, calling a function. If we have to, we can give it, let's say, a variable a, and give it a space function, and give it a string. Let's say hello. Okay, what it does is it printed hello after it. Yeah, so basically this is how we give an argument to a function in Python. It's pretty easy. Now, the next thing, imports. Okay, so imports, how we do imports in Python is firstly we need to have two files. Okay, in this case we have an external module called math. We've been doing imports in C. We do the include statement, and the include statement is it includes an external library like stdio, stdio.h, or std lib. Okay, these are external modules or libraries that we include. So we get the functions defined in these libraries. All right. So if we want to include some sort of external library, what we do is again import. Okay, that's all. All we need to do import. Let's say we want a math library. Okay, because we need to print pi. Okay, now in any other language, again we would have to do what 3.14 as an approximation, not in Python. Okay, now this is what happens. We imported math. We need to do math.py. Okay, pi is a function in the math module, and that will give me, yeah, pi to enough digits to, let's not approximate. Okay, now if we can do things like define another name for this, and let's say we can import only pi from math. It's all up to us to streamline a program. Let's say we only import pi from math, and we want it to define it as our function. Okay, not as some external function we have to call, saying math.py each time we want to call it. So how we go about doing that is import. It's like we say from math import pi. Okay. Now if I run this, this will throw an error. Why? Because math.py does not exist. We haven't imported math. It doesn't know what math is. We have pi though. All right. So that's one way to import something. And then we can give another name for it. Let's say there's a very big complicated name for the module. Okay, and we don't need one function, we need all the functions. So we can't just go for this particular method of import. Let's comment that out. The comments as we learned before. From math, okay, we cannot do that. So we can do import math as mathematics. Okay. Now this just overcomplicates things in this case, but in another case where the module is bigger, let's say the module was called mathematics and you need it as math. Okay. We would be using this and we would be giving something like math.py. Not math.py, whatever. This, if you try running this, throw an error. Now, why is it throwing an error? Because we named this as mathematics. We go mathematics. Think right. I cannot. There, we have pi again. So that's how we import Now, where all these will come useful is that when we're dealing with external projects, like a bigger project will have multiple files, multiple imports, a lot of files interacting with each other. That's when it come useful. So until now we have done comments, again single line, double line, loops and conditionals. Loops would be for loop and while loop, and conditionals are if, elif. You can just look at the syntax again. If condition and colon do something. Elif condition, something else to do. Else something else if the previous stuff fails. Okay, that's if elif, and then there is for loop. Okay, for loop again, for I in range or for I in this particular array, something like that. That's for loop. Then while loop, while condition, while this particular condition, do something. That's a while loop. And functions again, just going through definition, defining a function like this. Def function name, give some argument, give it something to do. We can have it return something. Okay, that's something I did show. If define some function, int returner. Okay, returner, and let's say we don't give it any arguments. All we need to do is return. Let it return 10. Hmm? If it returns 10, if I give it return 10 in the argument, so what it does is if I give print uh, int returner, okay, and int returner. Now, first case, remember, this is how we call a function. And just like any other programming language, we don't need semicolons. That's one thing. Now, what happens if we call this particular function? We won't get an output because we don't have a print statement. Yeah, see, it doesn't print anything. This says finish in 0 set, whatever. Mm, on the other hand, if we print this, right? Okay, we didn't call this. We get 10. So what it does is it returns some variable. We can store it in, let's say, A and print A. Again, we get 10. Again, this is useful when, let's say, we're writing some program that requires, a function returning some value. We've been dealing with returns in C, but it's really optional in Python, and we don't have to declare a void. So that's that. And we can do things like lambda functions. Okay, this is something we have not touched in. If you are a bio student, let's say, and you're taking PRC for the first time, this is not something you would have done. So if say y equal to lambda x and return x, okay, we can do this. Okay, lambda. Okay, so what this is doing is, this is a function. This variable is defined on the basis of a function. If I am to do this, x into 10. Now, if you notice, this particular function does not have a name. It's an anonymous function. Okay, y is not a function. Y is a variable, and it stores the value of whatever we give it. We are giving y the argument of 10. Okay, we are giving a variable an argument of 10. Now that goes to this lambda function. These are called lambda functions because the keyword lambda. And this is particular anonymous function. And x is the variable we get as an argument. We can give it multiple arguments, but yeah, that's how to scope whatever. When we give it 10, what it does is it goes to x and does this. Okay, whatever we give here, it does that. That's and stores whatever the result is. Lambda functions always return something, and this stores it in y, and we can access it later. That's how lambda functions work. Now these are generally used when you have to shorten your code. You need like a single line of code. When it's a lot of it pretty gets a lot of confusing elements in it, and to avoid that we use lambda functions. We don't have to define another function for it. Now, okay, functions and inputs. Okay, now example problems. Now we've been dealing with examples like bubble solve or recursion based factorial. Okay, we've already done a bunch of those in C. Now we have to, if you want to port that over to Python, first things first, the nice thing about Python is you can do sorting like as is. All right. If we give an array like that, 1, 4, 1, 2, and 32, whatever, if we get a dot sort, and if we print a, we get it all nicely sorted. So we do not need a function that goes, we not need bubble sort. Like, but it's nice to know. It's nice to try out things. So for that sake, we're doing it. And then we'll do recursion based factorial matrix multiplication. I mean, if you can try these out. Okay, we're not doing another class till Monday. So you can, try translating whatever programs you've been given in PRC homework to Python. And it's way easier. So yeah. Now, one thing I wanted to show is how to do, how to interact between Python files. Now, these are the Python files I'm going to use. Now, these are just Python files, like .py files. Try.py, test.py, egg.py. Okay, these just these three files that I've created. They don't have much. Now, this try.py has so much. Okay, I'll get to it. Egg.py has a printing function, and try.py is where we're calling it. Yeah. So if we look at close this thing. Okay, if we look at egg.py, what it does is prints, "Hi, I am an egg." Okay, and now let's say this is our main function. All right, our main code runs from this try.py program. Now, how we go about doing that? We define a main function. Now, this is not strict, does not execute something if the main function is not found. Right? That's a thing. Okay. So it's nice to have. So it's nice to know. Define a main function. This it's just like any other function. Define is a keyword we are using. Def main and egg.print. Now how we get egg? That is this module in this is done like in this particular fashion. Now, if it was in some other particular folder, we would have done something like the folder name. Now, when I use angle brackets, just notice that it's not all Python syntax. I'm just showing you things. The folder name. Okay, okay. Folder name dot Hello? Am I am I back? Hello?
Yes.
Okay. So anyway, so basically I'm calling this and the name, okay, we are using the special variable called name. Now name is this thing that's defined when this particular program is created. It's special because it's not like another variable to declare. Instead, it's something that Python makes up of its own, and name equal to main. We are checking if this is the program being run. All right. Egg.py, if it had a main class, it would not run because we are only importing one particular function from there. Now, if name equal to main, okay, what we're trying to say, if this is the program executing the main function, all right, if this is the program that is being run, then call the main function or do something, all right. And this is, I just want to bring this up because it's like part of most syntaxes. It's conventional. So if you're going to GitHub and you're going to look up some project, most likely you'll have one of these, and usually by convention they won't have these brackets. It look like this. Now this is being called in the main function, and it has egg printer. Okay, now since we have imported egg printer, that's right here, and yeah, it lets us execute it. Okay, no extra complications. It prints I am an egg, and that's in the other file. So this is how you interact, you know, between files. This is how you attach files. This is how to get a function from another file. Now, if we want to go for something that's harder, let's. Now, this is an example program. I don't expect you to get this straight out. Okay, this. Okay, this looks a lot complicated than it should. Don't worry about it. Now, what this program does is it takes a matrix and spins it. Okay, um, it spins the outermost string clockwise, and the next one anti-clockwise, the next one clockwise, and that's, yeah, it basically does that. So what we're giving it is an array. Okay, this is one of the extra programs. If you want to try out during the weekend, just go ahead and try out. It's, since you know most of the things that's required for this, you can just go check it out. So what it does is this. Yeah, so what's happening is the outermost string is rotating anti-clockwise. The next string is rotating clockwise. So yeah, how we go about doing that? I am right. How we go about doing that is, if we give it an array and we have to iterate it in such a way that it loops over like this. Okay, now that's part of the puzzle. We've learned about for loops, so we can use a bunch of for loops and say for I in range a. Now here in this case, a is what I'm defining to be this beginning index. Okay, for I in loop this index, go from here all the way to here, and the next for loop looks at this and be like, okay, I've reached the end, and from here I have to go down. Okay, so that's how I solved it. This is like a puzzle program. If you want to try it, go ahead, solve it. So how we go about doing it is index it like this. Okay, somehow index it like this. Any method, up to you. How I did it is 4 for loops that ranges from a to b minus a. Now functions. Okay, we've defined a couple of functions here. Let's look at those. This is very complicated, so don't expect it. Like, I don't expect it to just get it straight out of the box. Don't worry, it's just a puzzle. So define spin. Okay, spin is this function that is responsible for spinning the matrix. This defines screen clear. Now, if I'm running it from a terminal, you could see that a properly animated, display of this matrix spinning. Now, that I can't really show in this particular terminal. I can show it if I'm going to. Sure. Okay. I'm using Linux, so your path variables will be different. I mean, your path. Okay. Your path will have a backslash. Okay. So if you want to run this in this particular way, use a backslash, copy the paste, go do cd and copy whatever this path to your file is, your folder is, go there, cd your folder, then say Python. Again, according to you, if you're using Windows, it'll be just matrix system. Name it that. Anyway, you can see that it is clearing the screen each time it does, a new frame. Now, how I'm doing that is I'm doing an import. Okay, I am importing OS. That's the only import I'm doing here. And OS, what it lets me do is it lets me control um, the terminal on an operating system level. So os.system, I can do CLS for a Windows system, NTs for Windows. Okay, these are specifics for the program. You don't need to know that. This is how we call this function. And what it does, this is the argument I'm going to give it. Now, again, notice this particular it's call of an if block. Okay, this is a conditional that I'm using. If this particular OS equal to NT, do a CLS. Okay, that we've done ternary operators. This is a ternary operator. This is how we do it in Python. Okay, CLS if this condition is true, this condition. If the os.name is NT, Windows calls itself that. Else do clear. Clear is a Linux system. I'm using a Linux system, so yeah. Now this is another function. All it does this one takes in an array. Okay. Now I'm showing you this program so you can see a lot of things in action. And a variable just shown like if you take an argument for a string, it's not it's not that it has to be a string. In Python, variables are dynamically allocated, so you don't have to give it a data type. You can give it any array. You can give it arrays. You can give it structures. You can go crazy with it. Okay, in this case, we are using an array, and we're going for I in range, whatever that array length. We could also do for I in range that array name, and we can ask it to print. Okay, this is the function I defined to print the matrix. Some particular conventions again. Functions should be verbs. Okay, these are just conventions. I'm just saying it for the sake of saying it. Functions are usually verbs, and yeah, it's Python. Python has nothing to do with it. Just by coding, it's nice to have. Okay, this is how we define Python functions, and yeah, this particular one again takes in an array, looks for the length. Okay, we've done length of an array, done it yesterday. Asha did it. Len, this function checks the length, and I'm storing it in L, and this is what I'm using to iterate it across this. You don't need to understand this. Just showing you. Again, we are using a while loop here, while this particular condition. Python is not very strict about its brackets and syntax, and you can do crazy things just like this. Okay, I'm just ignoring the the brackets. It's fine. Python is very chill. Another thing, Python is a fun language. Okay, you don't need to be very strict about it. Anything. Python is named after Monty Python, so it has a few Easter eggs. Now, when we are discussing import, I have to show you import this. Okay. Now, this Easter egg Python developers put in since Tim Peters, okay, Zen of Python. It is a bunch of things. Yeah, if you want to check it out, go ahead, import this. That's one thing. And yeah, program is still running. So we've covered a lot. We've covered if conditionals, comments, loops, functions, imports. Now about example problems, we can do translations, and these are a couple of sites that are really useful for Python. All right. Anytime. See, when you're coding, you don't need to know it. Okay, we are not coding for an exam. If you're coding for a project, and it's, let's say, our own project for now, when you're trying out things, when you're learning the language, you can always go to Geeks for Geeks or W3 Schools. Okay, geeksforgeeks.com or w3schools.com, and you can try out. You can get code snippets. It's always useful. So yeah, that's another thing. Um, Always refer to these. If you have any doubts, just type it out and you'll get answers. All right. Don't be ambiguous. Don't wait for someone to tell you something. Always just go ahead and try out things. Try out these. Okay. Bubble sort. I'll do recursion now. Uh, Recursion in Python. Okay. We are going to define a function called factorial. Now, Python math has a factorial function. So using that is ideal, but no, whatever. We are going to define a function called factorial, and we are going to give it n. And we are going to define. Do we need a main function? Not really. So we're going to ignore it for now. Factorial 10. Okay. Let's assume factorial has a print statement, and it's not going to return the 10 factorial of 10. And that's why we're just calling it here. We are not saying print factorial 10. Okay, we're just going to give the print statement inside. For now, it's just for show anyway. Okay, print, if I call the function factorial n, um, factorial of n, what does it do? N into n minus 1. Okay, what is it doing? Basically, what it's doing is, will it print the factorial now? I don't know. It won't, because not what it's supposed to have. So when you're doing stuff, just try out things. A factorial of n. This won't stop at 0. That's another thing. If condition. Okay, we are using a lot of things that we discussed. So when you're doing a real problem, we can try out all these things we learned. N not equal to 0. Not equal to 0. Okay. Again, notice this. I have tabs here, tabs here. Indentation is what matters. It is not curly brackets. Okay. Else. Done. Again, what is showing error? Else. Okay. I did not give that. A lot of errors. Okay. Look at that. What's happening? Now, when we're doing problems, again, we run into errors. That's one good thing. And okay, what I want to show you is Python. In this case, runs line by line. Hmm? So we get errors on each and everything. How we are doing it. So what happens is, in this case, non type is returning something. It's much better to return. So it's printing in Python directly. Never mind, I'm going to print it outside. Also, try out things. If you don't, you probably won't learn the programming language. So just go ahead and do that. Okay, it gave me some answer. Two, yay, yay. Okay, we're getting kind of what we want. This is recursion because the function is calling itself inside itself. Okay, it's calling itself, and that's basically a translation of what we did in C. So all of you, if you want to learn Python, what you have to do is whatever code you know, okay, whatever logic you know, you don't have to code up new logic. Whatever logic you know, you want to try it in Python. For loops, you can try for loops. You can bubble sort. Okay, I'm not doing it because we already have a sorting algorithm, sorting function in Python. But you can just try things like this. Okay, I already did this. You have a long weekend. You can try these two: matrix multiplication and bubble sort. You've already gotten assignments for PRC, so you have problems. Just take those problems and you have flowcharts, figure out the logic, and try it in Python. Okay. So again, if you have any doubts, go to these sites. Again, what we've covered is this: comments, loops and conditionals, functions, definition, calling, imports. Now we know how to do file interactions. Now we know how to do imports in Python. Now we know how to do if statements. Now we know how to do loops. Okay, with that, thank you. That's the second day of Python. Thank you for the 6 of you there. Okay.